5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
This is About Space, America's return to space, with news and information on our U.S. space program. Is your host of About Space, David Denault.
Welcome, and thanks for joining me today. So, how good are your math skills? Well, in a new scientific discovery, an ancient Babylonian tablet reveals an astonishing formula. We know it as the Pythagorean theorem. Well, if you like math, don't miss our report next, as America and the world is listening to About Space Today. Ever dream of an island getaway at an all-inclusive resort? Or going on an island-hopping cruise to multiple island destinations? See sun-bleached beaches and swim in the azure waters of the Caribbean Sea. Call today for your special discount prices to your island getaway. This is a special offer for About Space by calling 877-747-8631. And let's go and explore the islands of the Caribbean. Welcome back. If you have ever taken advanced math classes, well, you probably had to memorize the Pythagorean theory. But did you have any idea how old this theory may have been? From Unsolved Mysteries.
3,700-year-old Babylonian stone tablet gets translated and changes history. We often hear tales of archaeological breakthroughs and ancient artifacts changing our historical, sociological, and cultural understanding of societies, both modern and ancient, but it is much rarer for our understanding of maths to shift so significantly. But an ancient stone tablet donning the name Plimpton 322 or P322 has done just that. P322 was first uncovered in the early 20th century by archaeologist, antiquities dealer, and Indiana Jones inspiration Edgar Banks. The tablet was discovered in modern-day southern Iraq and is now being held at Columbia University. The tablet displays 4 columns and 15 rows of numbers inscribed in cuneiform, a writing system used and developed by the ancient Sumerians of Mesopotamia. Interest in the Babylonian tablet picked up in the 1940s, when the cuneiform writing was recognized as numbers that reflect the Pythagoras theorem, a mathematical theory that most teenagers are familiar with. Teens all over the world have memorized this theory verbatim. The square of the hypotenuse equals the sum of the square of the 2 other sides. The discovery and use of this theorem in Babylonian times has sparked a great deal of discussion, lasting for decades. Mathematician Dr. Daniel Mansfield and his research team from the University of New South Wales in Sydney, Australia, were studying P322 after seeing an image of it whilst designing maths courses. Mansfield said, I'm sure it's trig, but how? The endless rules of trigonometry have haunted many people, high schoolers frantically memorizing for exams, and graduates who still get nightmares. But P322 did not display endless rules of sine, cosine, and tangent. This trigonometry had a makeover. From the Greek astronomers who were long credited with first uncovering trigonometry to the modern-day usages, we have always used the rules of sine, cosine, and tangent, figuring out angles and approximate measurements, rounding up to make these complex numbers functional. But the Babylonian tablet could be telling us that not only was there another way all along, but that they found this way first, beating the Greek researchers to the punch by 1,500 years. In this Babylonian approach, complicated angles have been replaced by ratios. Mansfield described P322 as a clean and easy way to use trigonometric table. The team unravelled the tablet's meaning and concluded that the lengths of the sides were calculated in ratios, not angles. Mansfield discusses the revolutionary aspects to this tablet, explaining that whilst we may prefer to stick with angles and not shift the status quo, the outside perspective is amazing, reflective of an ancient society and a simpler approach to mathematics. Dr. Mansfield stated, we have to really get outside our own culture. Mathieu Ossendriver, a historian on ancient science from Humboldt University in Berlin, reiterates the value of this discovery, pointing out that the angles we use are only approximate, giving us rough figures we have deemed close enough. By comparison, the use of ratios is far more accurate, leaving the maths as unaltered and exact. Despite all the excitement that came with this discovery, there is still a good deal of speculation surrounding the use of this table. That P322 is an early trigonometry table and was used for architectural purposes, constructing palaces, temples, and canals. Could we incorporate ancient approaches into modern-day teachings of trigonometry? Only time will tell how practical the use of ratios is in trig, but we do know that the dreaded maths of right-angled triangles has been around for much longer than we thought.
A theory older than that of the Greeks? Some 3,700 years old? So how did you like this math lesson and mystery? As a reminder, listen this Friday, America in Space with Don Meyer from Florida's Space Coast, and have your family and friends join us each week. And to all our friends and listeners around the globe and here in the U.S., thank you for joining me. I'm David Denault, and this has been About Space Today.